Hey everyone, so today we're going to talk a little bit about doing graphs with parabola or quadratics. Now, specifically, we're going to talk about the features of a graph and kind of the mechanics of how to find everything. First off, let's remind ourselves of the standard form. Now, I like to write these in capital letters. You can write them in lowercase letters for your own convenience. The primary thing we need to understand is that each number is either a coefficient or a constant. A and B are coefficients. That means they're the numbers in front of our variables. When I ask A and B, I'm not asking for the X as well. I'm just specifically asking, the A is in front of the variable with a square. The B is in front of a variable without an exponent, and the C is, of course, our constant. Now, first thing we need to understand, C is our y-intercept. This is true for most of the functions that we do. A lone constant is going to be our y-intercept. That's just how it is. Now, this only applies when the function is fully worked out. So if we have to distribute before we get our y-intercept, we have to distribute this stuff fully before we can see our y-intercept. Most of the time. There are some exceptions that we can look at later on, but most of the time we need it in this form to see our y-intercept. Now, this is very important because our y-intercept will later on help us determine where on the graph we are. Speaking of distribution, let's talk about kind of the opposite. There's also the factoring. Now, this is why I like using capital letters, because it allows me to use the lowercase letters here. It allows me to use lowercase letters when I talk about the factors. Now, the A and B here have nothing to do with the A and B up top. The A and B here are, lowercase so that I can talk about the different factors. When we talk about factors, we're talking about the x-intercepts. And for our factors, we just set each one equal to 0. And solve like a one-step equation. Now, if we have a coefficient in front of our x, which you may end up having, you will have to do a two-step equation, but this is very much our unit 1 stuff. We separate them, we set them equal to 0, and then we solve for our x. Now, in general, the rule is we are the inverse sign of our variable. So we have positive A, positive B. We're going to have negative A, negative B. Again, wherever we hit on the X is going to help us determine shape and function. Wherever we hit on the X is going to help us determine shape and function. So let's take a look at an actual example for a moment. Let's take a look at an actual example, shall we? So we got our line, we got our y-axis, we got our x-axis. Let's do that. Now, we have x squared plus 4x plus 3. So we're going to do 1, 2, 3. Up, and then 1, to the left, and 3 to left. That's because, again, we have to remind ourselves of the inverse properties. Because we have a positive C and a positive B, we're going to have plus plus. Inverse properties tells us these are going to be negative. So -1, -3. Again, not the best graph, it's a little off kilter, guys, but it will work out for what we're trying to do right now. I guess I can make it a little bit better. There we go. That's better. Now, here's where we get into the last feature we need to know before we can really truly make our graph. That is called the vertex. The vertex is essentially a midpoint between our two x-intercepts, and it is our lowest or highest point. Now, when we talk about highest point, we're talking about negative quadratics or negative parabolas. When we add that negative symbol to the leading coefficient, or a, that will give us a negative parabola. A positive parabola shape looks like this. A negative parabola shape will look like this. So positive parabola, lowest point, negative parabola, highest point. 2 is going to be our axis of symmetry. That's just kind of an easy one, guys, because it's directly in between -3 and -1. -2 being the axis of symmetry. It is just a point on the x that creates a vertical line that will split our line in half. The vertex is the actual midpoint. Now, how do we find the vertex? We take that -2, which, if it's not easy to find, you can use the equation -b over 2a, which, if we do this, 4, so -4 over 2, because a is 1, b is 4, the negative equals -2. We see that pretty easily. Mechanically, all we have to do is plug -2 in for our x's. -2 becomes our x's. So -2 squared plus 4, -2 plus 3. -2 squared is 4 plus -8 plus 3. And we get a total 3 plus 4 is 7 plus -8, -1. So -1. Our vertex, therefore, is at the point -2, -1. So we put it right here. Now we have our fully realized line, and we can actually pull the equation out from here. We can actually pull the equation out from this if we like. I hope this has been informative, guys. The last thing I do want to mention in this video, all this stuff can be gotten using Desmos. The reason I'm teaching you the mechanical methods first is that I want you guys to kind of be thinking in this way. Desmos shouldn't be your go-to. Desmos is not always going to be available for every test in your life. It's also not going to be available every time you need to think something like this through. If you understand the mechanics and you understand how to use Desmos, it helps you a lot better, especially when we get to questions about interpretation of the data. I hope this has been informative. I hope you all have a good weekend, and I will see you soon.